Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 14 about gases, and this is Chapter 14, Section 1, Part 1. So we, like I said, are going to be learning about gases. So looking at gases, let's first talk about pressure and the kinetic theory. So, the kinetic theory of motion is a theory that explains physical properties of matter by saying matter is made of small particles that are in constant motion. So, using this theory, and as we know about a theory, it is an overarching explanation that helps explain lots of evidence and observations that we have. So using this theory to explain states of matter, and it aligns very well, so we know that it is true. A solid is a state of matter with a definite shape and a definite volume. Those are definite physical properties that are easily observable. So using the kinetic theory of motion, the particles are in a fixed position, but they are vibrating because they have the lowest amount of energy and the lowest temperature. So they have the least amount of kinetic energy, so they're kind of like, they can't move in relation to each other, but they're in place vibrating. And then liquid phase has a variable shape and a definite volume, and that is because the particles are touching but flowing over each other because they have a little more energy and a little bit higher temp, so their kinetic energy is a little higher. Give me a second to copy that down. And then gas, where we're going to spend our time this chapter, has a variable shape and a variable volume. The particles have lots of space between each other. The particles are in continuous motion, and they collide with each other and are bouncing off each other because they have high energy and a high temp, so they have the highest amount of kinetic energy of those three states of matter. So let's dive into gases a little more. They're going to collide with the walls of their container. And the kinetic theory of motion, as applied to gases, or kinetic theory of gases, explains the physical properties of gases. So what do we see about gases? They are colorless and have a low density because they have very high kinetic energy, so they're zipping around, so the particles are very far apart. So most of them don't have a color. They are highly compressible. So since they have low density and the particles are very far apart, you can bring them together and have compressed air. And also, they will expand to fill any container. So if you give them space, they spread out as far as they can. What else do we know about gases? Well, we know they exert pressure. And we know that pressure is the force per unit area. So how much force is being put on how much area. And it's measured in pascals. And 1 pascal is equal to 1 Newton of force per a square meter. So a meter by a meter. The pressure from the air around us is called atmospheric pressure. And it is actually a lot higher than you think. It is 15 pounds per square inch. So for every inch, you have 15 pounds of pressure. And you have a column of air 100 kilometers above you that's pushing down on you. So why don't we just collapse? Well, our bodies evolved to be in this pressure, and also it's on all sides, so it is balanced, top, bottom, sides, all that. Okay, a lot of times you'll hear about STP, or standard atmospheric pressure, and standard temperature and pressure. STP, standard temperature pressure. So the standard pressure for, when we talk about STP, is exactly 101,325 pascals, or about 100 kilopascals. Or there's this other unit you'll see frequently, ATM, 1 atmosphere. So the pressure The atmospheric pressure at sea level is considered 1 atm, or it measures 101,325 pascals. Also, you might be familiar with this term, millimeters of mercury. A lot of weather is given in millimeters of mercury. Old barometers used to actually be mercury, so it was how many millimeters the mercury would go up, because it would push on the open container of mercury, and then it would push it up a container, like a little thin-walled tube. And so as the atmospheric pressure got higher, it would push it up higher. So 760 millimeters of mercury, or torr, named after Mr. Torr, is also atmospheric pressure. These are all units of pressure. Okay, what else should you know? Let's apply that kinetic theory of motion to pressure. Gases at higher temperature are moving faster and have more kinetic energy and exert more pressure. So if the temperatures are higher, you have more kinetic energy, and then the particles are moving faster, and so they're going to hit the walls of the container more frequently and with more force, and so therefore you have more pressure. So that makes a lot of sense. Another thing gases do is they will diffuse. So diffusion is the spreading of molecules throughout their surroundings. So in diffusion, the particles move from high concentration to low concentration. So if you were to spray some body axe in the corner of the room, it would eventually spread out to fill the whole room. And gases at a higher temperature will diffuse faster because they're moving faster, so they will spread out faster. And kinetic energy depends on mass and speed. Yep, we know kinetic energy is like 1/2 mv squared. So the mass and the speed determines how much kinetic energy it has. So if you have a heavier molecule, it has, at the same temperature, it's going to have the same kinetic energy. So if mass goes up, speed goes down. So heavier molecules have less speed at the same temperature. So heavier molecules are going to diffuse slower than light molecules. Question for you: which molecule will you smell first when released across the room? Vanilla or sandalwood, given that vanilla has a molar mass of 152 grams per mole, and sandalwood has a molar mass of 222 grams per mole. So write your answer in your notebook, please. And finally, how does this affect me? So pressure variations in large masses of air have large impacts on weather patterns. So hopefully you've heard about high and low air masses or weather systems. And storms are created when like a low pressure system hits a high pressure system, or vice versa. And so it depends on, are we going to have beautiful weather? Are we going to have a thunderstorm? Is it going to be gray and rainy all day long? So, example, will it rain today? Will I have a softball game today? These are all things that are determined because of pressure variations on large masses of air, which depends on gases. So that is the end of 14.1. In our next video, we will tackle 14.2. I will see you then. Bye.